Hello everyone, my name is Yoojung and I'm really excited to share this work with the UbiComp community today on behalf of our research team members. The title of our work is Towards the Design of a Ring Sensor-Based ML System to Achieve Optimal Motor Function in Stroke Survivors. Let's get started. So let's start with a simple number. Do you know how many people in the US are suffering from a stroke? Any guesses? 100,000? No. 200,000? No. It's more than that. The answer is 800,000. It's even more than the population of Seattle. Don't be too surprised just yet. Around 75% of stroke survivors go through long-term motor impairments in the upper limb. Look at this video. Do you see this patient doesn't use the affected arm as much as the other arm? This is called hemiparesis, which means impairments in the upper limb can be prominent in one of the two limbs, as you can see in this video. Once stroke survivors are discharged, this hemiparesis might become more chronic. It can largely affect their performance of activities every day, which leads to lower quality of life. So, stroke survivors end up starting very long and difficult and even tedious outpatient rehab therapy sessions. The goal of this rehabilitation process is to improve patients' functional performance of their affected limb. Unfortunately, the functional improvement achieved due to the intensive in-clinic rehab right after the stroke does not always last unless patients continue to use the affected limb when they are discharged. For example, for some reasons like the learned non-use, forgetting to use the affected limb, or pain, patients usually don't use their affected limb as much as they have to. This problem leads to our research question: how to monitor stroke survivors' upper limb performance in their daily living? And going one step further, how can we design an mHealth system to help stroke survivors self-monitor their affected limb performance in their daily living? We used finger-worn ring-type sensors because they are capable of capturing both gross arm and fine hand movements, contrary to wrist-worn sensors, which are conventionally used in the previous studies. Using those sensors, we conducted a mixed method study. As a quantitative evaluation, we first wanted to validate whether our ring sensors can measure clinically relevant information regarding stroke survivors' upper limb performance. We collected and analyzed a set of sensor data from 25 stroke survivors in the experimental setting. We found our proposed measure, the duration of active bilateral limb use, shows a strong correlation with the existing clinical measure, motor activity log. If you want to learn more about this, you can find the details in our paper. We also found that our finger-worn sensors show higher convergent validity than the conventionally used wrist-worn sensors for all the clinical measures that we use in this work. As we found that data collected by our sensors can be useful in the clinic, we wanted to investigate design requirements for mHealth system for patients and therapists. To do so, we conducted semi-structured interviews with 25 stroke survivors and 7 occupational therapists. From the interviews, we learned the current rehab practices and ways to leverage the sensor data to fill in the gaps for the current rehab practices. We identified 4 major components of the current rehab therapy process that should be reflected in the mHealth system, such as goal setting and adjustment, steps to achieve goals, reminders and cues, and involving formal and informal caregivers. If you're interested in designing an mHealth system, please find the details in the paper. We provide more engaging and vivid stories with the real voice of our participants. We believe our study contributes to providing promising directions for the design of a self-monitoring system that encourages the effective limb use with data-driven and patient-centered feedback during stroke survivors' daily living. Thank you for listening. If you have any questions, please check out our paper or just contact us. Thank you very much again.